Hello everyone, I welcome you all in the online session. Today we will learn about circuit diagram, about conductors and insulators, and about applications of electricity. Circuit diagram. A circuit diagram is a simple way of showing an electric circuit using symbols. You can see in the picture, these symbols are circuit symbols. Picture A is a symbol of a cell, which has a negative terminal and a positive terminal. Picture B is symbol of a battery. Picture C is symbol of a wire. Picture D is symbol of a bulb. Picture E is symbol of an open switch. And picture F is symbol of a closed switch. Now we will learn about conductors and insulators.
From the previous modules, you learned that electric current is the flow of negatively charged electrons which move from negative terminal to positive terminal. And for the current to flow, a complete and closed conducting path is required, which is called as an electric circuit. And this electric circuit is established by using wires. Now the question which I want you all to answer is, can any substance be used for making connecting wires? Or is there some special property that substance should have to be used as a conducting wire? And before that, let's come to another question. Why do we actually use a wire in an electric circuit? Yes, naturally to provide the path for the movement of electrons. But does all the material allow the easy flow of electrons? So let's understand this concept by taking a daily life example. So as you go to your school in a school bus or a van or be it any other way, don't you find such situations when it starts moving very slowly? And while you are traveling, you may encounter things such as the speed breakers, the pits, the potholes, the road diversions, or maybe some repair work going on, and then of course the traffic signals. And what do these things actually do? Yes, they obstruct the smooth flow of traffic. Or in other words, we can say that they offer resistance to the movement of vehicles. So what is this resistance? Resistance means the ability to oppose the movement of something. And in electricity, there are some materials that offer least resistance, such as when the electrons they flow through copper or silver wires. So they move quite freely without losing any energy. While there are some materials that offer more resistance, like you can see in the case of tungsten and chromium metals, where the motion of electrons through tungsten and chromium metals, it is opposed by their inherent characteristic, which is known as resistance. And the materials which offer least resistance and allow an easy passage of electrons or electric current to take place, we call them as good conductors. Now, can you tell me the name of such materials that are good conductors of electricity? Okay, so if you take a wire and if you remove its plastic covering, then you can see that it is made up of reddish brown colored substance which is called as copper. And among metals, silver and copper are good conductors of electricity. But as copper is cheaper than silver, that's why it is commonly used in making the wires. Now the copper wires, they are used in domestic electric circuits and in devices such as your phone chargers, the microphones, the transformers, and many more such substances. Now you may ask that why metals such as copper, they are used in making wires. Why can't we make use of non-metals for making wires? So students, if you zoom into a metal like this, then you can see that it has metallic atoms which are immersed in a sea of electrons. And you can visualize this arrangement by imagining a series of peas embedded in a ball of candy floss. And here peas represent the positive metal ions and the candy floss it represents the cloud of free electrons. Now due to the presence of freely moving electrons, metals conduct electricity. As when you switch on a closed electric circuit, the electrons they start flowing from negative terminal and drift towards a particular direction, interacting with the neighboring electrons and ions, and thus generating movement within the field of electrons. And this is what causes the flow of an electric current. Now students, here I want to add another piece of information for you all. The path of the free electrons is not straight. They still move in zigzag manner. And by colliding with the neighboring electrons, ions and atoms during their course of journey, they finally reach towards the positive terminal of the cell or the battery, thus resulting in the glowing of the bulb. Now what happens in case of non-metals? Why can't we make use of non-metals in making wires? Well, most of the non-metals, they are almost devoid of free electrons, and that's why they are bad conductors of electricity. But students, you must remember that there's a non-metal that can even conduct electricity. Can you name it? Yes, it is graphite. And like metals, it also has free electrons, and that's why graphite is said to be a conductor of electricity. Now, if there is a good conductor of electricity, then should there be a bad conductor or a poor conductor of electricity as well? So students, you are thinking it right. Poor conductors do exist, and they are materials that allow the electrons to pass through them. But then they offer a lot of hindrance or resistance to the flow of electric current. The electrons, they lose a lot of energy by flowing through the poor conductors. And this loss of energy by electrons, it appears as heat energy. So students, can you now think of such materials that are poor conductors of electricity? So pure lead, tungsten and mercury, they are the metals that are poor conductors of electricity. They offer high resistance to the flow of electric current. And now there are some materials that are so stubborn that they don't even allow a single electron to pass through them. And so they have very low electrical conductivity. And students, they are called by a special name. You know what's that name? Yes, such substances are called insulators. And insulators are the substances that do not allow the electric current to pass through them. And it is so because they have no free electrons. So can you give me some examples of insulators now? So if you talk about dry wood, plastic, rubber, glass, bakelite, these all are examples of insulators. So with this,
Now we will learn about applications of electricity. The discovery of electricity changed the lives of people around the world. It has affected almost every aspect of our everyday life. Many developments were possible only due to electricity. Electricity led to the development of light bulbs, heating systems, and cooling systems, which have improved the quality of people's lives. Electricity provides power for computers and mobile phones, thus drastically changing the way people communicate. It is also used as a medium for the transmission of signals over long distances. Without electricity, facilities like X-ray, photography, and scans would not be available in hospitals. Most manufacturing industries rely on electricity to run their units. Saws, cutters, conveyor belts, furnaces, and many other types of systems and machinery are run on electricity. Electricity plays a key role in many other fields, such as entertainment, transportation, and space technology. We cannot imagine our lives without electricity. As we are living in an innovative era where we find inventions of high tech machines, and to run these machines, we need electricity. So, this is the reason why we cannot imagine our life without electricity.